Hey
Hey,
man, yeah.
all right.
What?
Oh, he said hello. All right, perfect. So I will go ahead and do a quick intro. Welcome, everyone. This is the final workshop for Akashathon 3 before submissions are due this Sunday, December the 1st. Or is that, I believe, yeah, that is Sunday. Oh my gosh, the year's going by so fast already. Really excited for this final workshop. The topic today is open source AI tutorial. And we have here Shadik from the Akashathon community team. And I'll dish it off to you.
Hey, so nice to meet you guys. Today, we'll be downloading a open source model from the Hugging Face library. As you can see, I have Hugging Face open right here. And you can open it on your own browser. And this is basically a library of tons and tons of open source models that you can use on your own machine or in your own project. Uh, The overall layout of this workshop is we're going to load in a model from Hugging Face. Then we're going to deploy it using some kind of API. We're going to set up an API so that we can deploy it on Akash's network. So if all of you navigate to the Hugging Face website, you'll see something like this. If you go into models here, this data card here, you'll see all of Hugging Face's open source models. There's about 1 million, 1.1 million models for you to use. Um, there's a number of different models you can choose here. I'm going to choose a text generation model from the Quen family. And I'll be using the Quen 500 million AI because this one's quite small. You'll see this one, mini LM. I'll be using this one for its, just because it's very small, so we can get started very quickly, and I'm on a pretty crappy laptop. So if you press on this, you'll see the data card for the model shows up. And under use this model, if you click this drop down, you'll find that there's several different options here. We'll be looking at this libraries tab. So this libraries tab basically includes any Python libraries that make it simple to download this model from Hugging Face. You can see here the transformers library is available to us. If you press on this, it'll give you uh, instructions on how to load the model in. So right now I'll switch to an empty folder in VS Code. You can choose your own IDE, it doesn't matter. Just open any empty folder, and in here, we're going to be making a Python file. I'm going to call it main.py. You can call it whatever you want. And in here, we're going to basically write the sample code given to us. So first we're going to need to download the transformers library. We'll actually be using Docker for this. So we'll take that in a second. If you don't know what Docker is, I can explain it in short when we get to it. But for now, right, from transformers import, and we're going to be importing two things here. The auto tokenizer library, or the auto tokenizer class, and the auto model for causal LM library. You'll see this is exactly this line of code here. Auto tokenizer, auto model for causal LLM. These are the classes that contain the functions we will use to download our model from Hugging Face. Uh, so since this is a transformers model, a text generation model, we actually need to download two things, the model itself and a tokenizer that comes with it. You'll see this is what the tokenizer, auto tokenizer class is for. Because you can't directly feed text into a model. What you have to do is you have to pre-process it a bit with a tokenizer. So let's first download the tokenizer. We'll say that our tokenizer is equal to the auto tokenizer class dot from pre-trained. This means that we will be taking a model that has already been trained. And in here, we're going to pass in the name of our repository. So if we go back here, this is the name of our current model. I'm actually going to store this in a separate variable. Oh, because I'm going to be using it again. So let me zoom in a bit too. There. So the tokenizer is equal to our auto tokenizer class dot from pre-trained and the name of the model. And in exactly the same manner, we're going to download the model. We're going to say the model is equal to auto model for causal LMs. This is the second thing we imported. We're going to write from pre-train, download a model that has already been trained, model underscore name. Now in here, you can also add a couple of more arguments. What I like to do, especially when I'm demoing or prototyping, is take the torch D type and decrease it to a float 16. Now, what does this mean? Well, firstly, you'll see that it's showing an error in Torch. That's because Torch is a library for handling anything related to AI. And we haven't imported it yet. So we can simply import Torch up here. We're going to download these through Docker in a bit. But what does this line do? What it does is it says to our model, instead of using the default bit, I think for this model, that would be 64 bits for each number, decrease it to 16 bits. What this, if you're not familiar with a float is, you can tune out this part. It doesn't really matter much. It's mostly for those a little more involved. Using a lower lower quantization of the floats will of course make the model worse, but it'll make it better for downloading it fast or deploying it very easily and simply, which is why I'm changing it to float 16. So let me add a comment here. This is downloading the tokenizer, and this here is downloading the model. All right. So it's really just that simple. I think now we can start kind of using this model and our tokenizer. So what I'm going to do is, well, first I want something I want my model to work on. So I'm just gonna say my input text. You could also call this a prompt. Let's say it's hello, very simply it's hello. And now what I'm going to do is I'm going to tokenize this text with my tokenizer to turn it into a readable format for my model. It also does some extra things with embedding spaces, but that's for later. So the inputs to our model will be equal to tokenizer, and we're going to give it our input underscore text. We also need to give it another value of return underscore tensors. This will be equal to PT for PyTorch. So we want our output to be in a PyTorch format for the next steps. So what is the next step? Well, we're going to generate our output. So our output will be equal to model.generate Yeah, just all right.
Perfect.
All right,
Thank you.
great. All right, yeah, I'll repeat it.
Yep.
So yeah, I was actually thinking of going over it anyway. So first, we define a variable to hold our prompt text that we're going to generate on. And then we tokenize this input text into a value that our model can use. So you can think of it as turning it into numbers in a way, but it does a little more than that. We will also be passing a return tensors argument into here. This simply means that we are changing the format of our tokenizer so it returns a PyTorch, that's what the PT stands for, a PyTorch tensor. This is simply for the specific model that we're using. You will usually be using a PyTorch model, so this is an important step to remember. Let me comment that. Tokenize, this step is called tokenizing. Tokenize the input text into a special format for the model. And then we'll be generating the continuation of this hello text using the inputs. We'll also be using these double asterisks to unwrap the dictionary that tokenizer returns into arguments for the generate function. So this is generating an output from the inputs. And then the last part is simply extracting the actual output text from the variable outputs in this case, because output is actually a collection of two items, the actual text and an attention mask that isn't relevant for us. We only want the text. So that's what we're doing here. And then we're simply printing the output. Now, to actually run this code, you can obviously run it locally if you've downloaded Transformers and Torch. There's no problem in this code. But we will be using Docker to do this instead, because that will be necessary for when we deploy the model on Akash. So here I'll be making a Docker file, and we'll simply make it from Python. I'm not going to add a specific version here because it's from Python, because whatever. Then we'll be defining the working directory. Let's just make this /app to make it simple. And we will first copy in a requirements file that I haven't made yet. But I can make it right now, requirements.txt. What are the requirements then? Well, we need the transformers library, we need the torch library, and we also need two other things that will come on later. It's the fast API library, and lastly, UV corn. These are for deploying the API that we will connect our model to in a bit. So I want to copy requirements.txt to the local thing. And then we want to pip install -r requirements.txt. So this will install, we have to run pip install. This will install the requirements into the environment. And lastly, we want to run cmd uv corn dot hang on, I don't completely remember how this went. Let me get my notebook here. Wait. Unicorn, yeah. Unicorn main dash app. This will become relevant later. Actually, wait, I apologize. For right now, just write Python and then main.py. I forgot I haven't actually set up the app yet. So just compile the main.py application in the Docker file. And now we can go into the terminal and we can say Docker build. Let's give it a name. Quen model. Quen underscore model dot. And let's build this. And should go, this went quite fast for me because I've already done this before, but it might take a while for you. And then what I'm going to do is I'm going to say Docker run, and I will be using the -it flag for integrated terminal. This will simply make it so that I can view everything that's happening in my container right here in the terminal. And then lastly, I'm going to write Quen model, which was the name of my image. And can't open for message file directory. Oops. Yes, I forgot to copy the rest of the files in here. I apologize for that. Build it again and then run. Now you'll see it has started to download the tokenizer, and then it'll download the model. Now, like I said, since we're using a very small model here, you see it's going very fast. If you're using a larger model, like the actual full-scale Quen model or a llama or anything else, this will go a lot slower. You can see this model is only 1.86 gigabytes. Those models can be up to 40, 50 gigabytes. We might not wait for this entire thing to download if it takes too long, because we have limited time. I would actually like to show the output here. Like I said, this model is very small, so if you look at the output that's going to come up here in a second, it's going to be very bad. It's not really the best model. This is just like a concept. Like I said, you can use this for any model. Sometimes you'll have to provide a auth key from Hugging Face, so they know who it is that's downloading the model. But here in just a second, once it hits 1.86 gigabytes, it will. Oh. Oh, I apologize for this. I forgot one last step. It's decoding the output. The output needs to be decoded at the end, because these are numbers, they are not actual text. I apologize, I forgot. And actually, while we're also doing this, you should also write skip special tokens. This will just be so, because the model tends to add, special tokens that don't really matter or that aren't readable. So you want to skip those. I won't run this again because we'll have to re-download it. But if we actually look at the output that was printed here, this is actually what the model produces. It's a series of, these are IDs, they're numbers that represent each, you can think of it as word, not quite, but you can think of it as representing each word in our sequence. Now, if you run this now after we have pulled out the output text, it will actually return something that isn't a couple of numbers, but we'll do that at the very end because I don't want to re-download the model and everything. So this was the first step in our four-step journey. It's just setting up the actual model, the requirements, and the Docker file. Now we need to set up an API so we can interact with the model from outside. Right now we are hard coding the input text. This is not how we want to do it. We want to be able to add our input text as we go. So let's first put this entire process into one function. So let's call this function, I don't know, extrapolate, because we are extrapolating on the input prompt. Or let's just call this input text for consistency. We'll remove this line of code and we'll simply do that. And at the very end, we'll return our output text. So we have the input text here. We're tokenizing it, like I said, generating outputs, decoding the outputs after we're getting them, and then we're returning the text that comes out. Now to set up the API, we'll be using one of the requirements I added here, fast API. We're going to be from fast API, I want to import fast API with a big F and a big A. And this will be the object we use to construct our app. So write app equals fast API. This creates an app object. And then we need to create a couple of routes. If you don't know about routing or anything like that, this part is really, you don't really need to pay too much attention because this was the important thing. Now we're just doing the little things that we need to do for deploying it as an API. So let me first write an index. So here we'll be using decorator notation. If you don't know what that is, that's fine. App.get, the default route. And we're just going to return a dictionary with a message of, let's say, API is ready. So our API is ready. Now comes the important part that you do need to focus a little bit more on. We're going to be defining an infer route or an, let's say, extrapolate route that will take a prompt inside of the URL as a sort of input. And then underneath here, we're going to be defining, we can't name it the same as this. So let's say extrapolate route, let's call it, which will take in as a argument the prompt. It is very important that you name these the same thing because they'll be getting connected in the background with Fast API. And so what are we going to do here? Well, we're going to pass in the prompt into our extrapolate function. So we'll be getting our output text from it that we're returning here. We're going to extrapolate, and inside we're going to pass in our prompt. And afterwards, we're going to return a dictionary with our message of the output text. So this is how our API will work. Once you come into this link and you write your prompt into the link itself, it will run our model and it'll return you with the message. Now there is one more thing I want to do here. There can be a problem that we perhaps try to get this URL before our model has properly loaded. To avoid that issue, what we need to do is we need to firstly define our tokenizer and model as global variables, because what we'll be doing is putting this, functionizing this. So we'll be putting this into a load underscore model function that will load our tokenizer and our model. And right now we're going to have to write global tokenizer and model. So it'll be grabbing these two variables, the same variables that will be used inside our extrapolate function later. And we're going to write here app.on underscore events and in as a string startup. So what this says is that on startup, it will run this function, and once it's done, we'll have downloaded the tokenizer and the model, and then we're allowed to access it. So if everything goes as planned, we also need to do one more thing, which is come back here and write what I was going to write before, which is UV-corn. We're going to be using the UV-corn library that we installed in the requirements here. Going to be writing UV-corn main colon app. Now this value should have the same name as the name of the variable up here, and main refers to the file itself. Now I'm going to define a host. This host will be equal to, this is a local host, and lastly, we need to define the port, which is equal to, let's say, 8,000 for now. We'll also be needing to expose the port 8,000 for the same reason. Let me just check with my finished code if I'm doing everything correctly. Yes, there's also a reload flag. We don't actually need that. So here we have it. I forgot to put 2 dashes there. UV-corn main app, the host is our default, and then port 8,000 that we have exposed using the Docker file here. Now, if I go back to my terminal and I build our model once again, this goes fast for me because I've already built this before. In our run, we'll also have to define our port. We want the 8,000 port to map to the same port on our computer. And if I run this now, it will take a while. Hopefully we won't get any errors. And can I put in fast API? Fast. Ah, I see. It's not fast API, it's fast API with all caps in API. Apologize for that. Let me do this again. And there we go. Now, sadly, we're going to have to wait for the model to download again. But whilst it's doing that, I'd like to speak a little bit, go over everything that we've done here, because I sped through a bunch of things. So let me go over everything again, the API part of this lecture. What we're doing is we're defining an app object using the fast API library. And on this app object, we're going to use it to deploy an API. Once we start up our server or our API, we're going to first load the model, which is going to assign a tokenizer and a model variable with the two things. And then it's going to start up the actual API, which is these two routes. Now, the default route, it doesn't really matter much. It's just there because it has to be. The extrapolate route, what that does is it takes a prompt in the URL and it passes it to an extrapolate function, which we have defined here as taking the input text, tokenizing it, generating an output from it, decoding the output, and then returning the decoded output. And then we're simply returning that text as a message. So here you can see now it's telling us the application has started up and it's running on a local host. So if I go back to my browser here and I go to localhost port 8000 and I refresh this, you see it's saying API is ready. Now API is ready is what we wrote right here. This was the message that we were passing in on the default route. So now in the URL here, if I write extrapolate and I don't misspell it and I write say hello and I press this, it'll take a while because right now what's happening is that it's running our model in the background to create the output that I'm going to get here in a second. And you see there it is. Hello, I'm a 20-year-old female who has been diagnosed with breast cancer. I'm sorry. How sad. It's a cynical little robot. But congratulations, now you've created an API that you've deployed on the local host. So here I can write whatever I want. I can say goodbye. If I want to make spaces for URLs, you write %20. I'm not sure if this is, if you can see this, but it says %20 for a space. So if I write goodbye friend, it'll once again take a while. And in just a second, it will give me an output. Goodbye friend, hello friend, hello friend. And it's just repeating itself because that's what small models tend to do. They repeat themselves. But yes, we are done with the model and we are done with the quick and easy API. There are a lot of improvements we can make here. One big improvement is not to use global variables. You've probably heard that this is a bad practice, and that is true. We can also make this an asynchronous function and the like. But for now, let's just go with this and deploy this on Akash because that is the very last step. And to do that, we first need to deploy this or put our image up on the Docker Hub because that's what Akash uses. Now I've created a API repository on my Docker Hub. So this is the one I'll be pushing mine to. It's public, so you can use it as well, but it's best if you make your own for the practice. So let me close my server here or my API. What we'll have to do is we'll have to build, and in the name here, I'm going to, you can also tag it, but I'll be using the name here. And then I'm going to tag it with, let's say 4. So silly name, this is my username on Docker GitHub. This is the name of my repository, and this is the version I am giving to it. This isn't a Docker tutorial, so I'm not going to go in depth about this. But yeah, so now I can push this image I have created to Docker and tag does not, and this will go very quickly because the code is actually exactly the same as the previous version. But if I go to the Akash console now, so you can obviously do this on the console. Akash has a website to make everything simple. In here, you're going to have to connect your wallet and your account. This is a trial version I'm using. And if you go under SDL Builder, if I press on this, you will see that there's a lot of things we can add here. Inside Docker image here, I want you to write the name of your repository. So the name of my repository was butcherbushrike/API, and I'm using version 4 that I just pushed on this exact code. And then you can add whatever specs you want to your environment. So right now I have it on 10 CPUs. I have a hard time finding a GPU, so this is a small model, so we don't need to use GPUs yet. But yeah, so I've set it to 10 GPUs, 4 GB memory, 2 GB storage. And all I have to do here is press deploy. And okay, it has to verify me first. And it'll take a while, but soon I'll be able to press create deployment and I'll be given some bidders. I'm getting this question, can this run queries simultaneously? I'm trying to run an LMM, but couldn't run 2 different text completions simultaneously. So the thing is, no, not this. This can't run 2 things simultaneously. As far as I know, it'll do them one after the other. You can add that functionality in afterwards. But that is on the API side. You can search up how to run queries simultaneously with fast API. It shouldn't be too complicated, but no, not our simple code. But it will be just like a couple of improvements upon this. All right. It's, I wonder what happened. Deploy. Okay, there we go. This is the YAML file it built for us. If I create deployment, it'll ask me if I'm sure, and it'll start searching for priors. So while it's doing that, I want to go back here and add another thing to our code. Now, the reason I didn't add this at the start was because to keep things simple, I'm only using CPU here, but you would most likely want to connect your GPU to this. And the way you'll do that is using the torch library. So if we go up here, we're going to define a new device variable, and this will be equal to CUDA. Now, CUDA is a development framework by NVIDIA for their NVIDIA GPUs, and it's for it's basically the framework used by Torch and TensorFlow to run AI models. So of course, it's not guaranteed that your environment will have CUDA available. So I'm also going to write if torch dot is CUDA underscore available, else CPU. So either it's CUDA if it's available, otherwise it's a string that says CPU. And now we'll also have to put our model and our tokenizer onto the device. And that's done very simply with Torch. All we have to do is at the very end of this entire line of code, we simply write dot to device. So this will put our model on the GPU. And then down here on inputs, we also need to put our values that are going to run through the model. We also need to put them on the device. So we just write to device. And so this will put everything on the GPU. And just like that, everything will run on the GPU. So if this is the version you want to use, you'll need to build it and push it back as a new version and then do that. I won't do it for now. I'll just deploy the one I've already pushed. So let me just choose the first one that comes up here and create a deployment. Now it will take a while for everything to connect up and for them to download my image and start running it. Hopefully it won't take too long. If there are any questions, now would be a good time. Otherwise I can keep speaking. You'll see it's created a pod. and started a container. If I go to logs, when everything starts up, it'll, okay, I have a question here. No questions currently. All right. Well, then I believe I can continue speaking on this. Um, Changing the quantization of our model, which we did here, to a float 16 instead of the default. Most of the time, this doesn't make too much of a difference in performance, but the deeper your model is, or the smaller your model is, the more changing this D type tends to affect the model performance. So if you're deploying your model like officially on your website, perhaps not have this value at all, just keep it at the default. That usually tends to be the best performing model. But if application startup failed, connecting cached files. There seems to be a problem with connecting to Hugging Face here. An error happened while trying to look at the phone. Yeah, this doesn't usually happen. I believe this might be an error on the Hugging Face side or the provider. Let me close this deployment and try another. This does not usually happen. Like I said, it's yeah, it might very well be the particular provider I chose here. I would like to get this set up before we end the live stream. So I'll continue with a different provider. Now, generally, this works with other frameworks as well, such as Kubernetes. All of these libraries are available in the Tensor library. They're all available through pip. So if you're familiar with the package manager pip, I think we used it in the Docker file here. Pip has a bunch of libraries that you can install. If you don't want to use Docker, what you can do is let me just write it right here. What you can do is you can write pip install either transformers, you can write torch, you can write fast API. They're all available through pip. So if you're doing it on a local machine, that's how you do it. But since we're using Docker here, we only need to use the run command with this line, as long as we have this requirements text file. But yeah, let's see if this one works. Waiting for application startup. I'll be very bummed out if this doesn't work now. We can also go to my Docker Hub and see if you go into API, you'll see the latest one is the one I pushed just now, tag 4 minutes ago. And yeah. All right, it's running now. So if you go to Lisa's here and you'll see the forwarded ports value, if we press on this, it'll bring us to exactly the same page you saw when we were doing it on a local host. But now it's being done on Akash's website. And so this is available for everyone to see. So if we now do exactly the same thing, we write /extrapolate, if I didn't misspell that, and we write hello, we expect to see exactly the same output that we saw before. If we wait for a bit, we let the server run. you'll see here, it also says invalid HTTP request received. The only reason we're seeing that is because we're using a website. So I'm using Firefox here. You'll get the same thing on Chrome and Edge, because what they do is they request for extra information whenever you go to a website. If you don't want that to happen, what you can do is you can use curl. So if I bring out my command prompt, I hope all of you can see this. If I bring out my command prompt and I instead use curl, now curl does the exact same thing that uh, uh, these browsers do. We can go to, we can request. Wait, actually, let me copy. Oh, this would actually work because it's running a process right now. Oh, well, there we go. Okay, we got enough. Hello, I'm a 20-year-old female who's been diagnosed with breast cancer. This is exactly the same output we had before, except now it ran on the Akash network. All right. Uh, I think that's everything. Let me finish what I was talking about before with curl. So what we can do is we can take our URL here and we can say we want to access this URL. And if I press enter now, it'll send back the exact same thing it did before. But now we're not requesting for extra information like Firefox, Chrome, or Edge do. This was just like a little tidbit. It's not very important for most of you. So I'll just close that. And yes, this was the the object of our adventure. If there are any more questions, I believe we have about 10 minutes left to take any questions or speak more on the subject. If we go back here, you'll actually see this pad token ID to EOS token ID, none for open-end generation. What's happening here is it's complaining about a thing that I forgot to add. It's also complaining about another thing using the model agnostic default max length, blah, blah, blah. To fix these two errors in our code, what we can do is both of them happen in the model.generate function. So in here, what it would like is a couple more arguments. One is the pad token ID, which we're going to set equal to the tokenizer dot EOS end of sequence token underscore ID. So what this argument is doing is that our generate function usually wants it has a special token. This is one of the special tokens that were mentioned before. It has a special ID for a token that it uses, and it wants to know what this ID should be. And we're telling it we want it to be equal to the tokenizer's end of sequence token. And that was the first complaint we were getting here. And the second complaint, using the model agnostic default max length equal to 20 to control the generation length. As you can see, they say recommend setting the max new tokens to control the maximum length of the generation. So that's exactly what we're going to do in here. We're going to tell it the max length max new tokens equal to, say, 50. So yeah, that should be about it. I see there are no questions, so I believe we can perhaps end this here.
Awesome. And for those watching now or watching in the future, if you do have any other questions, you can join the Akash Discord. There is a channel thread for the hackathon And there's always someone online to help offer support on your projects. And then also, just as a reminder for everybody, there's only, I think we're down to about 5 days left. The submission deadline is now going to be 11:59 p.m. Pacific time. And so that'll give everyone a few more hours. But aside from that, thank you so much, Sharik, for hosting this very insightful workshop.
Yes. Thank you for having me.
Yeah.
All
Thank
right.
you. I'll end the stream now.
Right.
All right. Thank you, everyone. Take care.
Thank you. Take care.
Goodbye.
Bye.
Thanks.